Alright guys, let's continue to go through the 2024 paper 2 question 4. Part A says you have vitamin E, right? Figure 4.1. It exists as 8 different stereoisomers. Use the asterisk to mark each chiral center. Okay, so basically 8 stereoisomer means that there's probably 3 chiral center because 2 to the power of 3 is equals to 8. Okay, so as you scan across the molecule, right, benzene ring definitely no chiral. No branching on the alkyl chain, there's no chiral. So basically just focus in on the carbons along the chain that have branching. The last one we will not include because there is 2 identical groups, so it's not a chiral. So basically these 3 you should mark out with an asterisk. They have a chiral carbon. Okay, so that's for A. For B, right, they say that H compound extracted from bacteria added to separate samples of F and G. So F, right, they say that there's this reaction 4.1, which we have no idea what kind of reaction it is, but it does look like it is being oxidized because you get from alcohol to a ketone. But actually, if we work out the average oxidation state of carbon, right, it is actually +2. Okay, so if you want, you can work it out like this. Okay, feel free to pause the video just to double check. You're supposed to assign oxidation number to every single bond. Alright, so you can see that the 3 carbon average out, it is +2. And then when you work out the oxidation number here in the ketone, it is also +2. Alright, so no change in the oxidation state. So most likely it is just elimination because you have this formula, right? A, you get B plus a small molecule. Okay, elimination. Okay, what is the role of H? H is most likely a catalyst. Okay, it's most likely a catalyst that causes this to happen. Explain why H reacts with F but not with G. Okay, why does it react F and G? Because F and G, right, they are both enantiomers. So they have the same molecular formula, but the key difference lies in their stereochemistry. So your H, right, because it's extracted from a bacteria, it is most likely a chiral biomolecule catalyst. Okay, so most likely it will only react with another chiral compound that has the same like configuration in terms of stereochemistry. Okay, kind of like the lock and key mechanism. All right, so it is H is a chiral biological catalyst. Okay, only reacts with certain configuration, stereo configuration. Okay, so that's the reason why it doesn't react with G, because it doesn't fit the stereo configuration.